Very well, dear friends. Let's see how we can make a 90-degree bend from a PVC pipe. We can do it with this tool called a heat gun. Perhaps in other countries they don't have it, but it can be done with anything that heats up or burns, whatever. I put this cardboard on it so I wouldn't lose too much heat and could do it a little faster. Okay friends, the tube is hot now. The tube is hot. Let's go now. To do the 90, I remove my cardboard. And here I have already marked 90 degrees. We fold it like this. These 90-degree angles also come pre-made. But when we use factory-fitted 90-degree elbows, we have to use couplings. Now to walk a little faster, we wet a cloth or whatever we have. With water, regular water doesn't have to be cold water, so it cools down quickly. And now we have our 90 ready to use. Well, dear friends of the electrical consultation, we are here today in front of the panel because we want to lay a plastic or PVC pipe, as it's called here in the USA, to run some electrical circuits inside the house, which is where the electrical consultation is located, and to use it for the installations that we will be explaining on this channel. First, I want to show you the materials we'll be using here. In this small installation of the pipe, here we have a 90 with a connector that will go to the bottom of the panel. A coupling to join these two pipes. For that, we use cement that is used to join plastic pipes. Here we have several types. These two are used more for water pipes. Here we have what it says, electrical. They come in different colors. This one is gray, this one is gray, this one is clear, and this one is clear. I prefer using the clear one. So let's start working on installing the pipe. Very good. First of all, the panels come with the holes punched but not opened. We need to open them. They come in different sizes. Let's open it here. We remove this. We take the PVC connector with its nut. We put the connector in the hole. We tightened it enough here. We took the 90-degree elbow and the PVC cement. We applied PVC cement to the 90-degree elbow. And we insert it into the previously installed connector. We take a coupling and the PVC pipe that follows. We apply PVC cement and install the coupling. We applied PVC cement to the 90-degree elbow and the other end of the coupling. And we attach it to the 90-degree elbow. Then we take this LB that's going to go here so we can go through the wall with this little tube that will go through the wall. We put PVC cement in the small PVC pipe. And we glued it to the plastic LB, so it will go into the wall. This LB here has a cover with the purpose of, since it's not a 90, being able to remove the cables and reinsert them into the pipe. We put PVC cement at the end of the 90-degree elbow, and at the other end of the LB, we insert the small tube through the wall. And we join the 90-degree elbow to the other end of the LB with PVC cement. Then, to fix the pipe to the wall, we put one of these straps to secure it. There are 2-hole straps versions and 1-hole straps versions. In this case, I will use a 1-hole version. We're going to use this concrete drill bit because the outside wall is made of cement. We use this drill bit to break the cement, but behind it there's wood. In the event that the wall were made entirely of concrete, we would use Tapcom screws like these. In this case, since we have wood behind the cement, we're going to use wood screws. We have already opened the hole in the cement before. We have now completed the pipe installation. Now we're going inside the house to install the junction box. We're already inside. We have the pipe coming from outside. We have the PVC connector with its nut. We put it behind the box. We apply PVC cement to the pipe and the connector, and we insert the connector from the box to the pipe. And we fix the box to the wall with screws. Now we're going to run the electrical circuits from the electrical panel. Now we're going to run the electrical circuits that will go from this panel through the pipe to the inner box of the house. We insert the cable through the LB into the electrical panel. And we see that we already have the cables in the panel. We've left enough here to reach the inner box, enough here to go to the panel, and enough to go inside. Here we now use electrical tape to make it easier for us. And we go to the inner box. We used an LB because using a 90-degree elbow would damage the wall too much. We put the lid on the LB. Ready so that water doesn't get in. Okay, now we're going to install the breakers. We're going to use 1-inch wide ones. Because we have enough space in the electrical panel, we use these twin breakers when we need to make space in the panel. We remove the 1-inch ones and put in twin ones. And where there were two 1-inch feet, 4 twins fit. Of course, where there was one, there's room for two. We took the number 14 black wire and installed it in the first 1-inch wide 15 amp breaker. The breaker is off because I have power at the panel. Now we mount the breaker on the panel guide where the cable is installed and press the other end against the bars of the electrical panel. Okay, we have the first breaker installed. Let's put in the second one. We took the second breaker. As you can see here, they are 15 amp breakers. For 14 gauge wire, we must use a 15 amp breaker. The breaker here is off. We hook the breaker onto the panel guide by the cable end and push the other end inwards. We'll come back with the lid, but as we can see here, these are spacers to cover the gaps where we don't have breakers. In this example, no breakers were placed there. As we put two breakers down on the right, now the lid won't fit. We need to remove the spacers that were previously occupying the space of the newly installed breakers. Now we can put the lid back in place and tighten the screw that secures the lid. Here, we can put spacers like this, but this one is for the 1-inch ones. We're going to add spacers to fill these gaps that are the size of twin breakers. We have already installed insulators at the ends of the cables inside the house. Now we turn on the breakers, 1 and 2. We close the outdoor electrical panel, and we go to the inner box. We are now inside the house. Now we're going to check if the black and red wires are live. For this, we will use this circuit finder. We turn it red to measure voltages from 70 to 1000 volts, and in blue to measure voltage from 12 to 100 volts. Since we're going to measure around 120 volts, we turn it on in red. And we're going to check the red cable. When it sounds like this, or the light turns red, this means the cable is live. Now we'll look at the black cable. Now we will check if we have 120 volts between the neutral and the red wires as it should be. Between neutral and black 120 volts, and between black and red 240 volts, we should never work with the power connected. But in this verification case, we're going to do it. Those without experience shouldn't do it. Let's strip this cable a little. And we're going to put this cable from the meter on the neutral wire. Next, we take the other cable from the meter and we're going to test the black cable first, which, as we verified, is alive. We repeat, without experience, do not work with the power connected. First, install it, turn on the power, and look at the instrument. We connect the instrument to the black cable, with the instrument set to alternating current voltage. We've put black electrical tape on the cable connections to prevent short circuits. We can see that between the black live wire and the neutral wire we have 121 volts of alternating current. If we disconnect a cable from the instrument, we can see that the voltage drops to 0 volts. When we reconnect the instrument cable, it again indicates a voltage between 121 and 122 volts. This is the voltage between the neutral wire and the black wire. Now we will do it between neutral and red. We have already connected the neutral wire, and we've switched the other instrument cable to the red wire. We set the instrument for alternating current voltage. And we can see that between the neutral wire and the red wire we have 117 volts, slightly less than with the black phase wire. We turned off the instrument. This green cable is the ground protection. It works similarly to this neutral wire. However, the power supply circuits must be installed on the neutral wire, not on the green wire, and in another video we'll explain why. Here we have placed the instrument to demonstrate that between the red and black wires, there should be around 240 volts of alternating current. We turn on the instrument and you can see here that we have 239.8 volts of alternating current. In this box, which we will demonstrate in video 2, we can install a 120 volt outlet between these two white and red wires, and also a 120 volt outlet between the same white and black wires. If it's a single outlet, we'll use a single circuit, these two or these two. You can put two electrical outlets in the same box, using white with red for a power outlet, and this same neutral with the black wire for the other outlet. And we would have two outlets with the same neutral wire, but on different circuits. If we install a power outlet between the black and the red wires, we would have a 240 volt outlet. We must keep in mind that fortunately 120 volt equipment plugs should not be inserted into 240 volt outlets. In the metal box, we must put a ground screw to anchor the ground of the line. And we connect this box anchor with the ground that comes with the line. And we also add a little tail so it can be installed in the electrical outlets later. In the next video, number 2, we will see the installation of electrical outlets in this box. I hope you find the video useful and good luck.